Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graphs. So let us see our today's question. Our today's question says, all paths from source to target. So let me read the question. We are given with a directed acyclic graph. I hope you all know the meaning of these terms. Let me explain you. Directed. In case of undirected, what happens is if there is an edge from A to B, then it means there is also an edge from B to A in case of undirected. But in case of directed, if there is an edge from A to B, then it means there is only an edge from A to B. There is no edge connecting B to A. This is the meaning of directed. Acyclic means our graph will not contain any cycle. So we are given with a directed acyclic graph of n nodes, and our nodes are labeled from 0 to n minus 1. It means it is following a zero-based indexing. Our first node is 0 and our last node is n minus 1, where n is the size of the graph's vector which is provided to us. We need to find all the possible paths from node 0 to node n minus 1, and we can return them in any order. So the graph is as follows. Graph at the index of y is a list of all nodes you can visit from that particular node. Now let me explain you the question with the help of an example. See the example number 1. We are not provided with this diagram. We need to figure it out ourselves. We are given with this only graph vector. So very first thing is we are going to calculate the size of this graph vector. Why we are going to calculate the size? After calculating the size of the graph vector, we will understand the number of nodes present in our graph. In this, the size of the graph vector is 4. So it means nodes are present from 0 to 3. And so first step is calculating the size of the graph. Now, what does 0th indexing states? At graph at the index of 0, 1 and 2 are present. It means that there is an edge connecting 0 to 1 and 0 to 2. At index 1, 3 is present. It means there is an edge connecting 1 to 3. At index 2, 3 is present. There is an edge connecting 2 to 3. And at index 3, it's an empty vector. It means at 3 does not connect any node. So with this help of this, we are able to reach this particular diagram. Now we want to reach from 0 to n minus 1. It means from 0 to 3. How many paths are possible? The first path is we can go from 0 to 1 and 1 to 3. The second path is we can go from 0 to 2 and 2 to 3. So we need to return this 2 and this will be our output. 0, 1, 3, 0, 2, 3. So I hope the question is clear to you all. What we need to return? We need to return this particular vector. Now let us understand this approach of this question with the help of code. See, what we did, very first step, we have defined we are only provided with this graph vector, 2D vector graph. In line number 28, we have defined a 2D vector which we need to return. Our return type should be vector, vector int. That is a 2D vector, so we have made that particular vector. After that, in line number 30, we have calculated the size of the graph. I already explained you the reason why we have calculated the size in order to find the number of nodes present in a graph. After that, we know that we can store our graph in two ways, in the form of adjacency list or in the form of an adjacency matrix. Here we are going to use adjacency list. So in line number 31, I have defined one adjacency list vector in ADJ and size. Why size? Because it is following zero-based indexing. If it would be following one-based indexing, then our adjacency list would have been of size plus 1. But here zero-based indexing is followed. That is why adjacency list is of size. Then for int I equals to 0, I less than size, I plus plus, vector in temp equals to graph at the index of I. For int j equals to 0, j less than time dot size, j plus plus, adj I dot pushback graph I j. What we did in this particular step is, graph at the index of 0 contains 1. So what will this do? adj at the index of I is 0. adj at the index of 0 dot pushback 1. adj at the index of 0 dot pushback 2. It means this adjacency list is connecting these, representing these edges 0 to 1, 0 to 2. I hope you are all getting my point. So in this lines, we have defined the adjacency list. Then we have made one visitors array, vector and visi of size, and initially we have defined all the indexes with -1. -1 means that particular node is not yet visited. After that, the main logic of the program, we are doing a depth first search. That is, we are applying the DFS algorithm. So what we are doing the DFS algorithm? Visi start equals to 1, v1 dot pushback start. We have made two vectors, v1 and answ, which we need to return. v1 is our temporary vector, which is going to store all the nodes coming in that particular path. So we are starting with 0. So that is why we have v1 dot pushback start. After that, all the edges which are connecting the start, vector int edges equals to adj start. For int I equals to 0, I less than edges. We are traversing all the edges which are connected, all the nodes which are adjacent to start. Now we will check if it is unvisited, then we will check if edges at the index of I double equals to end. It means we have reached it till the end. Then we will v1 dot pushback edges at the index of I, answ dot pushback v1, and we will pop it. Otherwise, we are again going to call the DFS algorithm. In this way, after this particular DFS algorithm, in our answer vector, we will have all the paths from 0 to n minus 1. Let me show you the diagram. What we are doing in DFS algorithm. We have started with 0. So in our v1 vector, we have pushed 0. After that, we are seeing all the nodes which are connecting 0. Which all nodes are connecting 0? It's 1 and it is 2. So what we will do, is 1 unvisited? Yes, 1 is unvisited. So what will happen? 1 is also not is equals to the end. 1 is not equals to it. What is our end? At the index which we need to reach, that is n minus 1. In this particular example, it is 3. So 1 is not equals to 3. Then what will happen? DFS algorithm will be called. When DFS algorithm will be called up, initially our vector contains only 0. Now 1 will also be present in that particular vector. v1 dot pushback start. Now start is 1. Now all the nodes which are connecting 1. Which nodes are connecting 1? It is 3. So is 3 unvisited? Yes, 3 is unvisited. Is edges at the index of I double equals to n? Now this condition will become true. So what we will do, we will push 3 in our v1 vector, that is 0, 1, 3. Now, if we have reached till 3, that means we have done one path. That is why in our answer vector, we will push back 1 and we will pop the last element, that is 3. Now, the DFS of 1 is called out. So what we will do, v1 dot pop back. Now 1 is also removed from our v1 vector. Now our v1 vector contains only 0. Now DFS for 2 will be called up. And in this similar way, at the end, in our ANS answer vector, we will have all the paths connected. So after this DFS call, we will return the answer vector, which will be our answer. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.